Who has yet heard of matrixRTC so far? That's good. Who uses it on a daily basis? Okay, that's less. So the basic idea of matrixRTC is to build an RTC layer on top of matrix.
Yeah, I don't see it.
Okay, which is not persistent. And which is hence suitable for real-time stuff like video conferences, but also a whiteboard or whatever could be a good application example here. This is an initiative started for 2 or 3 years back, but I think we started 1 year ago to really try to spec it down properly and to have a concept where we try to be as orthogonal as possible. What I mean by that is that we don't mandate this one and only transport mechanism, but we are open and you can plug it to others. So today we would use WebRTC, of course, but going forward, nothing speaks against using web transport or what pops up at that point in time. Yep. Hey, come, no worries. How do we want to structure this session here best? So is it to explain the basis here, or do you have specific problems you want to discuss? How do we want to approach it?
I think an overview of the overall architecture would probably be a good starting point.
Okay.
I cannot provide that.
Yeah, then go.
I said I cannot.
You cannot. No, then I can start with it. So there was.
I will design.
Yeah. So
right now.
So the matrix primitives so far are that we have rooms. Within the rooms you have events, and events are persistent in that room like a database. Events can be a message, but it can also be so-called state events, which describe the room state. A subset of those state events are authoritative, power levels, whatever, and others you can just choose arbitrarily. And at a point in time, we decided that a call is the state of a room. Hence, it's a good idea to model it as within the room state. And at that point in time, the idea was, let's have a state event stating, yes, here's a call running, and another state event saying, yeah, I want to participate in that call. But what can possibly go wrong if 10 people at the hour are pressing the call button? You have 10 calls in parallel floating around in that room. So there's a big lessons learned here that we needed to improve the ownership here. So it started with shared ownership, and now we are found a solution where we don't have yet shared ownership, but basically what you do is we got rid of the regular call event, and now you're only indicating your own call participation, and from that information you can then infer if a call is running in that room or not. That helped a lot with so-called split brain calls, so now we are all in the same call. Then there's another thing which is was a tough problem, and that is basically within that room state you now can say, hey, I'm participating, but you can also say I'm leaving. But what happens if you have a network problem in between or your client crashes? Then you will never ever leave the call, and this is also not good. In order to overcome that, there are different solutions. One is that you could update an expiry timer, but this states a compromise of messing up the database with not so much important information and the trade-off about how long you would wait until someone is really then leaving the call. And in order to tackle this, within the element call team, we found a solution it has the nice name futures internally, but how do we call it? It's
delayed events.
Delayed events. Okay, futures is cooler, right? And what you basically can do is that you issue your leave event in advance and hand it over to the home server, and then there's a heartbeat timer, and you can reset a timer, and if you stop resetting it, then it will throw the event to the DAG, to the matrix room, and then you're leaving the call.
And it's a feature that we've wanted to have in Matrix for a while anyways, just the ability to schedule an event for, I don't know, if you want to send something out to the company that you're working for on the hour, or whatever it may be.
Or if you write something very important in the middle of the midnight, but you want it to be XP the next morning, right? Yeah. Or a tea timer, whatever, right? So I think there are a bunch of interesting use cases you could do with this.
Did it implement? Is it a replacement for like self-destructing messages? I forget if redactions.
It was an idea, but it is the issue. The thing is, the futures are they are not federating. They are only implemented on your home server. And if you want to redact a message and then there's a net split or whatever, then this is not propagated to the other home server. So it's a bit complicated. In theory, it would be a good. It would work. Yeah.
Going back to, so you've got room state and participants in a call, they add their own state to the room to say that they're part of it, and they can say what transport they're using. This concept of a focus or a foci.
Yeah, you should talk about that as well, right? Yeah.
So try to design or propose the MSC in a way that the application and the transport are pluggable within matrixRTC, so that an application might be a video call, an audio call, a whiteboard session, I don't know, a third room VR, virtual world.
How are applications identified?
Just in the usual matrixy way of like m.call or m.vr.
Yeah, and basically for each application, you then also need to specify an MSC such that the application knows how to behave, right? But yeah.
So the idea that participants of a call need to be well behaved. They say, I'm having a call with this kind of application. And the participant also gets to say, I'm going to use this transport. For example, transports that have existed or exist at the moment are, there was a full mesh transport, full peer-to-peer WebRTC transport. There's currently the one that's most actively used is LiveKit based. LiveKit being an open source WebRTC SFU selective forwarding unit implementation. So using that, but theoretically it could use any SFU, any backend. It doesn't have to be WebRTC, and still the matrixRTC primitives should still work, even if we've moved to a different protocol. So where previously things have been baked in that assumed you were always doing full mesh peer-to-peer stuff, and actually we want that to, it makes more sense if that is one mode that you can operate in, but equally you might be in an SFU type mode as well.
On that point, it's also interesting. So Matrix is federated. How do you agree which SFU to use?
So that's in how things are at the moment. There's all the participants need to converge on a single SFU, but it would also make sense that you can converge on multiple ones and have more either backhaul links between SFUs to distribute the media, or you might even need to subscribe to multiple SFUs depending on whose media you want to be receiving.
Is there a way to specify like alternates, like please connect to this SFU over web RTC if you're in the web app, but just hit it up with TCP if you're on desktop?
Yeah, it's a good question.
Yes, my question was just, can you specify alternates as in like call up an SFU over web RTC if you're on the web client, but over TCP if you're on desktop?
The way it's written in the MSCs at the moment, no, but also it doesn't stop you from doing that.
That would be just a different backend implementation, right? A different MSC. So that is totally possible with the concept.
And we talked about that you could actually be publishing your media to multiple places all at once and letting people consume it in different ways depending on what it is. And that some of that could even, where what we've been working on is a m.call type of application, which is really all participants taking part in a single meeting, there are other things like more of a conference scenario where you're having more of a broadcast that actually you might want a different set of semantics and things in there. And it probably would make sense for that to be its own application. And then that would also have probably some different media distribution transport things as well.
If you have, in the scenario, I understand that right now you have only one SFU, which is LiveKit. In the scenario where you would be pushing to several different SFUs, I think it's the SFU role to detect who is the active speaker, or maybe to say, okay, we have 100 people, but I cannot stream 100 people, but I'm going to stream this, and this speaker because it makes sense. How could that work if you have something that is more distributed?
Yeah. So that's some ideas and thoughts to that. There's also another reason why large meetings are an issue, because we are using end-to-end encrypted media, and hence with individual sender keys, you need to share in a very short amount of time a lot of key material. So, and if basically the publishers are only 3 or 4, it's manageable, but it's basically if everybody is online per default and sending, let's say you have 100 participants, then n square, wow, that's a big problem here. So what that needs is kind of moderation, that you can be on stage, and only people which are on stage are publishers. So you need basically some moderation around it. And with that mechanism, cascading is also more easy to establish.
Do you really need a full peer-to-peer key relationship for a room, though? The idea could be that, like, anybody involved in a room should have permission to access that data. You could sort of agree on a single AES key.
You could, but it's basically then you need something like the Raft algorithm or whatever to get consensus on this single shared key. So because Matrix itself is decentral and eventually consistent, this is a hard thing. And so it is way easier if you have ownership about your media and how you encrypt it and have your individual sender key. That makes it a lot easier. But on the semantic level, if you have a call, let's say with 1,000 people, you can argue if that is if there's a secret in that call.
Right, yeah.
Now that we're talking about 1,000 people, how is it about compatibility? Like, I know from like 3 years ago, back in times when I was implementing WebRTC and Fluffy Chat, we were not at the stage of matrixRTC yet so far. Back in times, we had like each matrix client had their different implementations. I so far didn't touch the topic. Now I'm confronted with the topic by work again. I need to be compatible with the family stack. And at least from their documentation, I know that they do use different signaling than element calls does, for example, even though like already a year ago, we've seen demonstration that interoperability works. Like how is state of compatibility between all these implementations out there?
So to be fair, the MSCs are not yet in FCP. And I think that is what is needed, right? We need a document where it's described how it works. Yeah. That's basically it.
So basically, if I implement it nowadays, I need to decide on whether I'm implementing on my own, compatible with the element implementation, compatible with the schematic specification, or compatible with
the schematic is easy. They don't have video for now.
Yeah, but we plan on having video. Or on the other hand, family, they use like a weird combination of LiveKit and full mesh calls. So there's no unified approach. So
yeah, basically the MSC should it be, right? So push that we get the MSC in shape, and then I think that would be the best way to bring it forward.
Do you have a proposal, having given you worked on from the other side, as in because Element have been doing a lot of work on this, and you've kind of been working on from the other side of things. Do you have, other than things going through the MSC process, do you have a proposal of how, or an idea of how it could work better?
I don't have a solution to this. I mean, that's a general problem of the Matrix ecosystem. We have 100,000 different implementations everywhere. I mean, already look at inner element. You have different implementations in element X. You have different implementations of everything in element again than in legacy element in hydrogen. Like, There is no one matrix. I guess time will tell. From my personal perspective, I'm a huge advocate of LiveKit, but well, I see advantages in full mesh implementations as well. But I do not see a solution to fastening up the process of finding a solution for an ecosystem.
I think so if we would have more time and more people working on it, I would love to have a full mesh backend also specified. No, because this is basically removing third-party dependencies. That's the only point. What I really like about LiveKit is there are very smart people who had a look at WebRTC that what a mess. we make a developer-friendly layer around it, and it just works. And there are really a lot of super smart things included. So if you have a, let's say 100 people in a call, but you only display 3 on your screen, you're only subscribing to those 3, and also only in that media quality, how the tile size is presented. That's really smart. And if you would do all this on your own, that is a journey, right? So that's from that perspective. So time to market, that's super cool, and it works quite nice. So that's cool. The challenge here is, if you want to do something like cascaded SFUs or whatnot, right, then you need to upstream it back to LiveKit, and I'm not sure if that is in their interest. So this is something which is a bit more involved. However, we also had a thought experiment that to get more into the matrix DNA, that there's also a good way how you could do the semantics of cascading, also based on LiveKit, where basically, as you already explained, that you could connect to multiple SFUs, like a full mesh, and you would basically publish your media to your home SFU, and you would then connect to the other SFUs to receive the other media, and that should just work. You wouldn't have the inter-site bandwidth benefit, no? But besides that, the semantics are the same. Yeah, but let's see. That is another MSC we need to craft, and let's finish what we have in the pipeline first, and then stick to that.
Right. I can speak briefly to like your question about how does that work if you are subscribing to media from multiple SFUs. So right, the SFU, each SFU does decide like who is speaking based on voice activity, but so the concepts of an MCU, which I forget exactly what that stands for, but it's a server that mixes all the media together. Yeah, and then sends it to you as a single stream, and an SFU, which allows you to selectively just request certain streams of video. Those are different. And so the idea is you would connect to all of the SFUs involved in the call, and then these give you just some lightweight metadata about what the participants are that they're advertising and who is speaking. And then your client would basically put the list of participants together and decide who is actually on screen based on the voice activity that's being indicated. And then you can actually subscribe to just those streams from the right SFUs.
What you could also do, that is a super, let's say, interactive method to identify who is the most active one, what I'm interested in. The other opportunity would be that on the metadata, those people would say, hey, I'm important, and then, right. Yeah, that is basically, I'm on stage, and then you already know which person you subscribe. But let's say, I think in the work adventure use case, maybe the speaker activity is more important.
We actually, basically, I was just thinking about how I can turn automatically, because there are different semantics. You're right. A small meeting is not the same as a large one. And one of my current questions was, how can we basically switch from one to the other, like semi-automatically? Maybe from 50 people, you say, okay, now it's a large meeting. But maybe it's not 50, maybe it's...
Where's the threshold is the question,
exactly.
Right? Yeah. And another example where you want to expose people in the screen is, we recently added the hand raise feature to Element Call. And of course, if you raise your hand, you also want to be in the visible area, right? Yeah.
raising hands implemented.
That's pretty cool. So first of all, credits to that goes to Milton. He started that, and it's using reactions.
So it's done with it's done with it as matrix. So it's done at the matrix layer, not at the RTC layer. There. I mean, did someone have a question about like when should you put things into RTC versus into matrix?
Not yet, but it's a good topic.
Maybe I thought someone mentioned that earlier. Like, yeah, how do you choose whether is it as a reaction a real-time RTC thing, or is it actually a persistent thing that exists in matrix?
I wonder this every day.
Like, how does the reaction event look in particular? Like what exactly is being reacted onto what?
To your call member event.
Okay, yeah.
Yeah, yeah. So there is a relation, which makes semantically sense. Yeah.
Can I also react like with the shark emoji or?
Yes, of course. we haven't hooked that up. We should, but we have also sounds. So test it. It's fun. I
do not want to hear my emoji.
Yeah. Yeah, but the question. So when do you want? Yeah. So I think if the data rate is lightweight and the timing is not too important, you could use the matrix layer. I would also say this, so moderation stuff like who's on stage and whatnot. This is something which is a good place to put it in that room because it's like a database. It will you don't need to build on top of the RTC layer then a consensus or whatever merging CRTT whatever style because matrix layer already does this. Yeah, maybe that is the guiding bit that if the matrix primitives give you a lot of benefit, like state resolution and whatnot, then you should use that. And if the primitives are already there, because reaction is a reaction, right? So if it's in a video call, okay, then you can visualize it. But in the end of the day, it's a reaction. Yeah.
The other thing to consider is the data that you're trying to communicate. Is it meant to be ephemeral, or should it remain in a matrix room history forever? Because of course that's how matrix works. You just add things and they're permanently there, unless you redact them. And this was kind of a guiding principle when going from the original like one-on-one legacy calling in matrix, where everything from the SDP offers is all chucked into just the room timeline and stays there forever. That we should try to be a bit more considerate about what we're actually using the room timeline for. But at the end of the day, if the matrix primitives just make sense, like reactions, it's kind of okay to just use it for stuff. Yeah.
So where do SDP offers and stuff end up now with the current like matrixRTC?
It's handled by LiveKit. This is the developer-friendly experience. It just works. So basically what that does is you have a WebSocket connection to the LiveKit SFU, and then there is a signaling layer. Yeah.
But when we were experimenting with just peer-to-peer WebRTC connections, I believe we just sent those through these like two device messages, which is a concept in Matrix where you can just say, I want to send this specific event to this this user's specific device, and then it's just sort of an ephemeral message that gets passed, and it exists outside of any rooms.
It's like peer-to-peer, but on the matrix layer?
Yeah.
More or less, yeah.
And I think it's guaranteed that those messages are also delivered, right? The two device messages.
In theory.
Yeah. Yeah.
When you announce that, I would like to be in a call state, do you specify what device is going to be in the call, or are you just as a user in the call?
You can also join a call with multiple devices. Yeah. So if you have a DM room and you have a desktop and a mobile app and whatever a tablet, you can join 3 times if you would like to.
Are there any concepts about like from enterprise video conferencing software? I'm familiar to features like dial-in using a phone line.
Yeah, you're asking a very good question. So
I know that's a bullshit idea, but customers will demand that.
so most of the time they're asking, is there a SIP interface? And for SIP there are 2 to 3 use cases. One is that they have very expensive room equipment which they want to use. And what I learned yesterday is that on the recent versions of the Cisco Room OS, you can run element call. So cool, for that use case, we don't need SIP going forward. Because the downside with SIP is it's super expensive because most of those devices can only handle one video and audio stream. So what you need, then you need to render a video conference into one video room feed. This is expensive. You need a lot of CPU cycles. And of course, it breaks end-to-end encryption entirely. For me, the only valid use case is if you want to dial someone from the telephone network, then you need a SIP bridge. Or if you want to use your matrix client as a telephone with a public number. For all the other use cases, I would not allow them because what can possibly go wrong, it will go wrong. And we have this very famous Taurus leak in Germany where someone from the German armed forces had a phone dial-in in a very high secure video conference and leaked some information because the phone call was intercepted. Yep, and if you don't allow it, it can't happen. So that is where I'm standing, but you're right, customers are asking and asking and asking and asking. And yeah, I have not a good solution here, to be honest.
Okay, yeah, but, I would object that this is not, that like phone dial-in is no longer necessary nowadays. I'm working in a company and let's say we have excessive fire rule and even we have internal communication software, which is sadly not matrix-based, which is a big enterprise conferencing system I won't name further. And it keeps refusing connections to their SFU from my device when dialed into the VPN. So basically I need to dial in by phone to any relevant meeting because firewall keeps blocking incoming WebRTC traffic. So there we are back at the enterprise customers. Yes. This is a sadly required feature.
Florian, how conceptually would it work?
Conceptually.
So yeah, how conceptually would it work? Would it be that you have, if you wanted to have PSTN dial-in people, would it be that you have a call participant who is going to act as that gateway, and then they would, so the end-to-end encryption would then be terminated at that call participant, and then it's passed on. PSTN would be unencrypted, but theoretically could be encrypted if it were via something else. So it becomes a bit more like a classic matrix bridging.
Yes, that is the path I would choose. Yeah. So in theory, with LiveKit, you can also do some SIP stuff, but I would not go that route because then our idea it's pluggable is not anymore true.
Yeah, I was going to say in terms of like interoperability, that feels like quite a good way to go. And presumably we could learn from all the missteps with bridging.
Yeah, and also, let's say if you're just talking about audio mixing, that is low hanging in terms of CPU cycles, but video mixing, don't do it.
so you could just forward on the audio and drop the video, for example.
So I would say the PSTN use case in terms of audio and audio mixing is fine.
I just want to announce that in 1 minute, there is in the room over there, in the hot room, a session about pluggable transports for matrixRTC. Okay. In case you are want to attend here. And in 30 seconds, there will be a session about crypto UX and invisible crypto. The session about how actually to deal with the crypto if your users don't expect to deal with any crypto because it's a completely different application like Work Adventure. And now you are asked to deal with some crypto stuff. Is this in parallel?